Hello and welcome to the engineering school. Today we will go through the fourth and last lesson in our CAD beginner series. This means that after this tutorial you will have the knowledge to create basic sketches, solid models, assemblies and drawings. Let's get started. As you see, we already have a part open. Now, to specify the dimensions of the part, we need to create a drawing. Now you might be asking, why do we need a drawing? We already have a CAD model. Now we want to make sure that our part functions as intended. That's why we have dimension tolerances, surface and geometrical requirements. Those need to be specified somewhere. Now it's true that we could specify it with PMI, but it would just be too much work if you had to open up a CAD model every time you needed to check something. It's far easier to print out a drawing or open a PDF document. So to create a drawing, we need to go back to the root directory, clicking on the exit icon right here. Once here, we click on the drawing sheet icon. Here you can see that we have different templates to choose from, and we can sort them by clicking on the roll down menu. We have different standards to choose from here. ANSI, it's the American National Standards Institute. ISO, it's the International Organization for Standardization, meaning the international standard. And DIN is the German standard. JIS is the Japanese standard. And GB is the Chinese standard. But we will stick to the international standard. Now let's choose the international standard, and you can see that all the sheets are sorted to be international standard. Now let's choose the A3 sheet format, this one, and the H after A3 means that the sheet is in a horizontal position. Okay, so let's go ahead and confirm it. This is what your drawing sheet looks like. You have a border divided in different sections around the sheet. Then you have a title block in the bottom right corner. This title block has different fields that need to be filled. For example, technical reference, who created the drawing, date of issue, part name, and so on. Now, this is just a default template. You would also want fields specifying the material of the part, the standard you use for the dimensions, surface tolerances, etc. This is done by creating your own drawing template. And a lot of these fields should take the information from the part and automatically insert it to the drawing. I will show you how to do this in a future video. For this example, we will just keep it simple and stick to the default template. Now to insert the part layout, we first click on the Layout tab in the top menu, and then we click on the Layout command right here. Now if this would be a multi-part file, we would have several parts to choose from here. Now we just have one part, so it automatically chooses that part. In the Layout command, we need to specify our view orientation. We can locate the view orientation by a corner point, for example, like this, or by a center point like this, or we just let ZW3D auto-orientate it for us, choosing auto. Now in the settings, we have an option to project the part in first angle or third angle. This means how your part is presented in the different views. Let's just do a small explanation on the first and third angle. Let me show you the symbols representing first and third angle projection. This is something that you need to specify on your drawing as well. So this is how the symbol looks for the first angle projection, and this is how it looks for the third angle projection. Now to explain the first angle and how the views are projected, imagine that this cone or cup, let's call it a cup. Imagine that this cup is resting on a table with the lip of the cup in contact with the table. Okay, so it's upside down. The lip of the cup is resting on the tabletop. and you are watching it from the top. So this is what it looks like. Now, if you would want to see the right side of the cup without moving your head, you would have to flip the cup over to its side to reveal the right side, and it would look like this. So now you see the right side of the cup. So that's why the right side view is on the left side on a first angle projection. If you would flip it back up again and flip it to the right side, you would expose the left side of the cup, thus the left view. And that's how the first angle projection works. The first angle projection is used by the majority of the countries. It's only a few countries that use the third angle projection, and the most predominant being the US. So let's go ahead and explain the third angle projection as well. So imagine that this, still being a cup, is resting with the bottom part of the cup on a table, just like a normal cup. The bottom part is in contact with the table. Now the tabletop is made out of glass, so you can see through it, and you are watching the cup from underneath the table. So this is what you see. You see the bottom part of the cup that's resting on the table, and you see the outside of the cup. You still see the same thing as you saw in the first angle projection. Now this is where it gets different. If you want to view the right side of the part, you will have to flip it over to the right side to be able to view the right side of the cup. So that's why the right side view is on the right side on a third angle projection. So this is the right side view in third angle, and this is the right side view in first angle. The difference lies in how we observe the object. I hope that I could clarify it a little bit for you. I might do a separate video in the future regarding the differences between first and third angle projection. Now moving on, let's choose the first angle projection. Here you can see that we can modify the view layout by adding or removing different views. For this part though, we only need the top view. So let's deselect the other views and change the main view to be the top view. So this is the main view, and let's change it to the top view. In the general settings, we can choose between different options on how to display the part. We also have an option to add the PMI from the part, if it has any. And then we have an option to set the scale. If you use anything other than the sheet scale, you need to show the scale by checking this box, okay? But we will use the sheet scale. Good, let's go ahead and confirm. And now we have our view set. So we can almost add all the dimensions from the top view, but we will need to do a section cut to be able to see all the features of the part. So this basically cuts the part where we add the section to help us show some internal features. To create a cut, let's go to layout, and we click on full section, then we choose the view, and then we choose 2 points here, and confirm by clicking on the middle mouse button, and then we place our section cut up here and confirm. Now we have a section cut. So let's go ahead and place the views somewhat in the middle. Okay, so you can see that the part is cut right here, and the arrows pointing at it is the way we are seeing the cut. So we are watching from this side and we are seeing the cut from here. That's what we see. Okay, so now we can see this small feature on the bottom of the part. To add dimensions, we go to the dimension tab up here, and the easiest way of adding dimensions is to use the quick dimensions command. Okay, so I will add all the dimensions, and then we can talk about adding tolerances and editing dimensions. Alright, so now we have our dimensions. We can edit them by right-clicking and choosing attributes. There you have all you need to modify the dimensions. Modifying the lines, the text position, the text, some general information regarding tolerances and other features. So feel free to explore this section because you can really modify it to fit your exact need. So let me show you another way. By right-clicking, you can also choose modify text point in this menu, and also modify dimension points, modify text, and modify tolerance. So let's add a tolerance to this hole, and we want to show the tolerance like this, and we choose what tolerance we want. Now it is a hole, so we have this tolerance table, and let's choose the whole tolerances. Now you see that all the letters are capital letters, so that's something that you can keep in mind, and I will do a future video regarding tolerances as well. Let's just go ahead and choose H7, OK, and confirm. Now it says diameter 30 H7, just like we wanted. So another neat feature is if you want to clean up your model, it's very handy to use the clean up dimension locations feature, because you can just select the view you want to modify the dimensions on, and then you set all the offset values in between the dimensions. Keep in mind that different standards have different values for the distance the dimension needs to have from the nearest edge of the part. Okay, so just keep that in mind. And there you have it. You have now created your first drawing. Remember that you will still need to add some information, for example, the view projection symbol, also what the general tolerances are, so that you don't have to put tolerances on everything. The standard we are using is ISO 2768. You can see that it is followed by 2 letters. The first letter applies to tolerances regarding linear and angular dimensions, and you can choose between 4 letters: F, M, C, and V. F being the finest and V being the roughest. The second letter applies to geometrical tolerances, for example flatness, parallelity, perpendicularity, and so on. And here you can choose between 3 letters: H, K, and L. H being the finest and L being the roughest. I will cover tolerances more in depth in another video. So I hope that you have learned enough to get started. Try to practice as much as you can on these aspects, and I am sure that you will make progress real fast. So that concludes our final lesson of the CAD beginner series. I hope that you have enjoyed it. Stay tuned for new lessons and tutorials coming up. See you on the next video.